Alright, this is Group 1's presentation on blizzards and climate change with Brendan O'Loughlin, Kyla Rowland, and Lauren Romero. So our hypothesis was that the increase in global temperatures due to climate change will lead to more intense blizzards in areas that do not normally receive major snowfall and blizzards. So the general outline of the paper was that warming climate due to climate change will cause a change in global weather patterns, including snowstorms and blizzards. And since these storms have a pretty big impact on human activities and the economy and just general human life, it's important to make predictions on how these storms will evolve in the future in order to better prepare for them. The first article, The Future of Epic Blizzards in a Warming World, encourages that blizzards will continue to intensify as climate gets warmer. And in the second article, contrasting responses of mean and extreme snowfall to climate change, the author claims that the amount of snowfall will decrease in a warming climate, but the resulting percentage of stronger snowstorms will increase. Just don't mind those transitions. Uh, so, uh, the gradual warming of the planet due to human activities is a process known as climate change, and is caused mainly by uh, emissions of greenhouse gases by human activities, and it's becoming a bigger factor in our lives as time goes on, and it's leading to a warmer average temperature overall around the globe that will cause a major change in snowfall and blizzards. Andrea Thompson in Future of Epic Blizzards in a Warming World writes that extreme snowfalls will become a larger portion of total snowfall events. And Paul O'Gorman argues that the annual mean of snowfall will decrease, but can increase in regions with very low temperatures in higher latitudes. O'Gorman uses a multitude of simulations and mathematical analysis techniques to display his point. And overall, there's still not very much research done on this topic, and there's an underlying unpredictability in the nature of these storms that we can't account for.
All right, so methods. So in Thompson's article, she goes for an observational analysis of the whole thing, while O'Gorman employs a wide array of analytical practices, including computer-based simulations, climate models, and mathematical analysis. These two methods are compared with observations in nature to provide credibility. There are several uncertainties that need to be taken into account, such as assumptions in the simulations. There are also a lot of technological limitations for this. Several factors that were not taken into account for the calculations and equations for the sake of simplistic estimates. For instance, that they only focused on the northern hemisphere, and there was not a lot of information on areas that did not usually get snow. All right, so Thompson presents that the expected snowstorm could likely produce a record-breaking snow of up to 2 feet. She explains that the reason this blizzard is going to be possible is because there is a large amount of moisture in the air, in part due to climate change, because the sun and the hot weather makes water evaporate, which then is held in the atmosphere, and then when the cold comes, it just falls intensely. Contrasting responses of mean and extreme snowfall to climate change uses simulations aimed to measure a difference in the snowfall rates for a control climate that is not altered by climate change and a warming climate. The two separate graphs were constructed laying out the data as a ratio of warmer climate snow amount to the control climate snow amount. That's figure 2. So yeah. All right. Graph A in figure 3 demonstrates that the extreme snow storms will become a larger percentile of all snowstorms, especially at a higher temperature. Graph B shows a direct comparison of O'Gorman's simulation approach to his mathematical and analytical approach. It's clear that the theory seems to prove, or rather provide credibility to the simulated models as the lines closely match.
Both Thompson and O'Gorman provide a multitude of observational and analytical evidence to support the fact that blizzards will intensify but will happen less frequently. In the future of epic blizzards in a warming world shows that the influx of moisture in the atmosphere will result in heavier blizzards. The evidence for this is computer-generated models that O'Gorman uses to support her claims, and O'Gorman is able to provide this data with a controlled space that isn't affected by climate change and a space that is already affected by it. There are a decrease in the amount of overall snowstorms, but a significant increase in the intensity of them. Both of these articles seem to be in a common agreement with other sources as well, such as one from National Geographic. They also come to the same conclusion that a warmer atmosphere holds more moisture, which will lead to heavier snowfall. National Geographic discusses other factors omitted by the articles, such as Arctic warming, water levels, precipitation, and the jet streams. There are many limitations to these studies, such as important factors left out for the sake of simplicity, a lack of statistics in the areas not affected by snowfall, and a focus in the northern hemisphere. In conclusion, we attempted to support our claims that climate change will result in an occurrence of more intense blizzards more frequently in areas that do not receive major snowfall. We found that our claim of a larger number of blizzards was actually contradicted for those areas. There's evidence to support the claim that extreme snowfalls will become more intense and make up a larger portion of all snow events. We observe that the climate change will bring less snowstorms, but the intensity will increase when they do occur. With all this evidence, there are some significant constraints to these studies. Location limits, computer errors, and altitude restraints were all obstacles O'Gorman faced during his research. Despite these errors, the information that has been provided on this subject gives us a better understanding and perspective on how climate change can affect blizzards in a way that we never thought before.
Warning, the following slides contain graphic images due to climate change. Viewer discretion is advised.
This is one of the few that maybe for us if we do not stop climate change soon.
Help fight climate change to save Dr. Breen.
Rest in peace, Dr. Breen.
Rest in peace, King.
And this is our reference list. Thank you for listening to our presentation. Goodbye.